Okay, so let's look at this graph. So here are some of the things that we know. I know I have a y-intercept at 0, 20. So 0, 20 is right here. I have x-intercepts at 5, 2, and -1. So I know that those are part of it. The other things that I know is that I have a point of inflection at 2. So right here I have a point of inflection. Everything before that is concave down. Everything after that is concave up. I know that at 0.26, so somewhere in about here, we are increasing between that and 3.7, so about here. We're increasing on this side, which means that we are decreasing here. Okay. The other thing that I can know is that my end behavior, it is a cubic. It is going to be that S shape, and it's a positive function with the leading coefficient. So we're going to start in the negative y's and go up to the positive y's as we're looking at this. But I don't necessarily need that in order to help us here. And the reason why is because I am increasing in concave down. So if I'm increasing, that means I need to go in this direction. But I also need to go in this direction, hitting that x-intercept, also our y-intercept. But I'm also concave down. So I'm going to be kind of looking at something that's kind of in this shape. So we're going to get a little bit closer here. And I'm going to start at this y-intercept, and we're going to work our way backwards. So we have something that looks kind of like this. Here. And this goes down forever. But I'm still increasing for a little bit before I turn around. So I'm going to continue to increase to about here. From here, I'm now going to be decreasing. I need to pass through this x-intercept, but I am still concave down, so I still want to kind of do one of these. Okay, now that I'm past this point, I'm now going from concave down to concave up. So I need to still be decreasing, but I need to start being concave up, which might look something like this. Okay, about here is when my function is going to change from decreasing to increasing. So now I want to turn it around and work my way up. We're still concave up at this point, so we're going to have something like this. If I did a little bit more, I might be able to tell what the maximum and minimums were. So I could have plugged in that 0.238 and the 3.732 into my original function to get those y values. But since we're just sketching it, I'm not going to stress too much about it with what we have here. So this might be how someone would use that function to kind of help us out in that analysis to sketch this graph. We already graphed it when we looked at those intercepts, so we can see here, this is what that function would look like if I multiplied it by 2, because that's what it's supposed to be. So we're going to look at something that looks like this. So if we look at it, our graph looks very similar. I may just not have enough of a minimum than I do my maximum. So once again, like I said, this is not something that we would ask you to do on the AP test. Sketching the curve, finding all the information is a different story. Something that they may ask you to do, though, is what we're going to talk about in just a second, which is comparing different graphs and deciding what is our original, our derivative, and our second derivative.